Imagine you're going on the internet and are reaching a web portal such as Gmail, let's say, for accessing your email. In fact, while you're doing this, a million other clients are doing exactly the same thing, trying to reach the web portal through the IP network. The service that you're trying to reach may be architected to direct your particular request to a specific site. And the architecture within that site may look like this. A whole bunch of servers, maybe on the order of thousands or even 10,000, within a cold, dark room, interconnected to one another through perhaps a high bandwidth communication backplane. And also, all of the servers are connected to data stores for processing requests that may be coming in. And the servers may optionally use the backplane that allows them to talk to one another for servicing any particular request. Any of the servers may be able to handle an incoming client request. Now, in the generic picture that I'm showing you here, the load manager that is sitting in between these servers and the IP network redirects an incoming client request to one of the servers. The chosen server may then process the query and answer the client. The role of the load manager is to balance the client traffic among all the servers. Basically, the load manager has to make sure that no particular server is overloaded. One of the characteristics of most of the giant scale services is that these client requests that are coming in are all independent of one another. Sometimes this is also called embarrassingly parallel, meaning that all of these client requests can be handled in parallel so long as there is enough server capacity to meet all the incoming requests. So the role of the load manager is to balance the client traffic and redirect them to the server so that no particular server is overloaded and all of the servers get equally utilized in servicing incoming requests. The other responsibility of the load manager is to hide partial failures. Because when we're talking about the scale of giant scale services and the kind of computational power that resides in the data center for servicing these giant scale services, they are humongous. There are 10,000 nodes. And when you have so many nodes, compute nodes and data nodes and so on, it's not a question of if something will fail, but it is a question of when something is going to fail. So the load manager has to make sure that it is observing the state of the servers and ensuring that the incoming client requests are shielded from any such failures that may happen internally within a particular site.